Trigonomic ratios. Now, first of all, before we even start looking at the functions themselves, we have to first know how to identify the sides of the triangle. And in that way, we'll be able to go on to the functions and easily just solve them like that. So now there's three, as we already know, there's three sides to a triangle. And each three sides has a name in this setting. So first of all, we have to identify which angle are we working with. So over here, we can see this is our angle. This is the side that we're looking at. So first of all, we have the opposite side, and that's pretty easy to get. If this is your angle, what is right on the other side of it? What is right opposite to it? It's this side, isn't it? So that would make this our opposite side. Now over here, we see this little box. Now what does this little box mean, or what does it represent? Well, it represents a 90. It represents a right angle, which means it's 90 degrees. So when we look at this and this 90-degree angle, that means this is a right angle. And we look right opposite to this, so we go like that. And then what do we see here? This side. Now what is this side called? It is called the hypotenuse, and it is the biggest side in the triangle. Now finally, we've identified this side and we've identified this side. Now what does that leave this side with? This is the adjacent side. It's the last one you'll be able to find, and it'll also be the one right beside the angle we're looking at. So this is the adjacent side. So now that we've identified all three sides, now we'll be able to look at the formulatic functions. So here are the three main formulatic functions right here. We have sine, cosine, and tangent. Now, what's an easy way to remember what these sides are or what these functions are? Well, that's where we have this. We have so for sine, which means so opposite over hypotenuse. Ka for cosine, which is adjacent over hypotenuse. And toa, which is for tangent, and that is opposite over adjacent. Now, you could just keep on saying this in your head a few times. So, ka, toa, or whenever you see sine, you say, oh, so, and you'll be able to immediately know what the ratio is. It's a really easy way to learn it. That's how I did, so I think it'll work well. Now, first, the next thing we have are three other functions, three other ratios, and these are less common functions, but they're still there and they could be used, so it's good to know them. And it's good because you don't even need to memorize anything else. It's a derivative from the main three. So first of all, we have CSC, and that would equal hypotenuse over opposite. But when we look over here, can we see any that's opposite to that? Oh, it's sine, right? So now if you look at the other ones, we have sec and then we have cot. You can, over here, you can see that this starts with the CSC and then this is a SEC, and they're kind of similar to each other. So what I've made is sine and cosine, they're best friends, okay? So these are their opposites. They share it with each other. So if cosine's best friend is sine, then its opposite is sec because it starts with an S, and it's just its complete opposite. And same for sine. Sine's best friend is cosine, so it starts with C, so it's the opposite of this one. Now tangent here is, he doesn't have any friends. It's sad. Yeah, it's really sad, but that's why he's cut out. You could remember it like he's cut out of the group. Cut. I know it's a stretch, but I think it'll help you memorize it. So remember that tan is cut out of the group. So that would be its opposite because it's not in the best friends group. So that's an easy way to remember how these are just the opposites of each other, except for tan, which is on its own because it was cut out. Now that we know all the functions, you'd be able to easily solve any questions after you've identified the sides, which one's opposite, hypotenuse, adjacent, and now that you know the functions, it'll be easy as cake for you to find out whatever it is that the question is asking of you. And here again is everything. And here in an example. So for example, they ask me, oh, I want sine O. So what would I see? Oh, sine equals so. So opposite over hypotenuse. So what is the opposite here? It's 4. What is the hypotenuse? When it's opposite to the square, 90 degrees, it's 5. So that would be 4 over 5. And here I am, I'm correct. Now, if they wanted the CSC, oh, that's the best friend, and that's the opposite, isn't it? So we already got sine O, that's 4 over 5. We just need to turn it around, and it's 5 over 4. See? So in that way, you could solve everything else. Oh, you see cosine. Oh, ka, adjacent over hypotenuse. And then you could do the opposite when they ask of you. And then tan, oh, toa, opposite over adjacent. And then you'd be easily able to just find everything. And then cut, remember, it's cut out of the group. So it shares its own opposite with itself.